Alrighty, we're continuing with functions today by talking about how we represent them in both a table and in a graph. So we have two different functions. The first one is y equals 3x minus 2. We can choose any value we want for x and then write what we get for y as our output. So if you can pick any number, pick easy numbers, right? Unless there's some reason why it would be easier to do otherwise, I usually do like -2, -1, 0, 1, and 2. Those are my go-to like 5 points. I can already tell I'm going to need to make this narrower. All right, so if I've chosen -2 for x, then I'm going to replace the x with that -2. And I'll do 3 times -2 minus 2, which is -6 minus 2, which is -8. And that gives me the point -2, -8. And again, I made up that value for -2. Or for y. Oh my goodness, for x. And I chose something small because I want to graph it, as you'll see in just a minute. All right, now I'm going to use -1 for x. Just replacing the x with -1. So -3 minus 2 is -5. That gives me the point -1, -5. 0 is usually an easy one. That gives me -2. And then I have a positive 1. 3 minus 2, of course, is 1. So that gives me the point 1, 1. And 3 times 2 minus 2 is going to give me 4. So now let's take this function or equation and represent it on the graph. And we can do that by just using these points that I just got, these ordered pairs, by choosing my own values for x. Here come the dogs. Sunday afternoon math videos and dog sounds. Lily's going to stand right next to me and do her heavy breathing. Lily, lay down. Nope, that's too close. Oh, Lily. All right, here's the point -2, 8. So 1, 2, to the left and then down. 1, 2, 3, 4, 5, 6, 7, 8. Here's 1 point. And I have the point -1, 1, 2, 3, 4, 5. I have the point 0, -2, the point 1, 1, the point 2, 1, 2, 3, 4. Here we go. Nice straight line I have here. Let's see if I can get a straight line through it. Beautiful-ish. With some arrows. All right, let's try this next function or equation next to it. I have 2x plus y equals 6. Again, I can choose anything I want for x. I'm going to choose my old go-to numbers here, -2, -1, 0, 1, and 2. Lily, lay down, lay down. I'm going to write my function here. Or actually, let me do this. This is even easier. If you know how, you can rewrite this function so that it's a y equals function. How could you do that? You could isolate this y by asking yourself what's happening to it and doing the opposite. So right now we're adding 2x to it. So if I subtract 2x from both sides, now I have y equals -2x plus 6. That's just going to help me input my x values quicker. Do you have to do that? No, it'll work just fine if you wrote 2x plus y. Oh my goodness. Remember what I say all the time. I don't start the videos over if I make a mistake because I don't have time. All right, so you could have written 2x plus y equals 6 there too, and still solved for y for all of the values you chose for x, but this way is faster when you already have that function or that equation set to y equals. All right, so I'm going to replace x with -2 and solve. So I have 4 plus 6 gives me 10. So my first point is -2, 10. Then I'm going to replace the x with -1. And I have 2 plus 6, which is 8. So my next point is -1, 8. And I usually love that 0 because it means less work, right? 0 plus 6 is 6. So my next point is 0, 6. Now I'm going to plug a 1 in for x. Whoops. Get -2 plus 6, which is 4. So that's my next point. And finally, I'm going to put 2 in for x. So that's a lot of points, right, that I'm using here. A lot of values for x. I would say you need at least 3, because if you do just 2 values for x, it's going to make a straight line no matter what. You're not going to know if you made a mistake or not. But if you do 3 or more and one of them is wrong, it won't fall on that straight line with the others, and you'll know to go back and fix it. So let's put these points on a graph. I have -2 and +10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it is 10. It's a 10 by 10. Well, actually, it's a 20 by 20 grid, right? 10 by 10 in each quadrant. Then I have -1 and 8 will be right here. 0, 1, 2, 3, 4, 5, 6 here. 1, 4. And 2, 2. Another straight line. Sort of. I wish I could remember how to grab the lines and move them. That's it, guys. So that's how you represent functions on both tables and graphs. Thanks for watching.